Hello and welcome back. In this lesson, we'll be using all the foundation nodes that we have built and incorporating them in one giant scene. We'll be adding new agents to our agent template and using the motion path tools to build the crowds. We'll polish our foreground characters with a layer of Vellum cloth simulation on top of it and prepare them all to be rendered in the next lesson. First, I'll dive into my agent template. Let's clear out this custom agent as well as our test agent. After cleaning up the nodes, I will duplicate them multiple times for each of the agent that I will be using in my final scene. So first, let's dive into any one of the networks. Here, we can verify if everything is correct. I'll just delete this material network for now, since we don't want it to be copied over. The layer name is incorrect, so I'll copy this agent name parameter and paste relative references. Let's duplicate this for now. I'll remove the agent clips and we'll add those at a later stage. Let's also clean up and remove the second output. So in this character, we are missing the for Vellum attribute triangle, as well as the pin group that we have created for our Vellum simulation. So let's get those added from another agent. So essentially, what we are doing right now is trying to make this setup as reusable as possible with minimal changes required. So by default, we can leave these groups as empty. I'll call this template. Let's just lay these out properly. In the future, you can also promote some of these parameters to outside the subnetwork to make it more easily editable and accessible. So let's get rid of all our existing agents for now. And using this template, we'll recreate all of them. I'll be starting with my mutant one. Let's dive inside the node and set up our project path once more. Switch to auto update mode. We don't have any Vellum simulation in this, so we'll leave them as it is. In the materials using mat extractor, I can quickly create a material for it. And finally, I'll recache my agent definition. Similarly, we can create all the agents to add extra variety, since our scene is going to increase a lot in size. I'll be adding one more mutant agent. All these agents are coming from Mixamo. So we have a second mutant, again with no Vellum simulation. I'll save it to disk. Once I know that our agent is ready to use, I'll flip the color of the subnetwork to green. Let's copy this template multiple times for each of our agent. We'll have a total of 10 agents coming in. Let's name all the agents that we'll be bringing in. For my generic crowds, I'll just call them male and female, since it will be easier to bring them in later using expressions. So now we can dive inside each one of these and start setting the correct paths and create materials for each of these. We'll repeat the same steps for all the agents. For our female and male characters, we'll be setting up the Vellum simulation as well. Let's connect our material to the Vellum nodes. Okay, so we'll have to turn off these nodes for the places that we won't be using these, since otherwise it seems like it will make a group, regardless of what our input might be. So once we have done that, we'll need to recache these again. So click on Save to Disk once more. Since we had already set up our for Vellum and pin groups for this agent, I'll just copy them over from my previous file. And we can recreate this material based on the new groups. I'll do the same for my second female character as well. So let's copy over both the attribute triangle as well as the pin group. And create materials for it. So we can verify we have our for Vellum material coming in. Once you have that, you can save to disk and mark it green. Now, for my third female agent, since this is a new agent, I'll have to reset the groups for these two nodes. So let's select the cloak and I'll pin the middle section of the cloak. Then we can create materials for it. Make sure your material subnetwork is connected after the wrangle that creates your for Vellum group. Otherwise, it won't be creating the second material. So let's create materials. Now, we can save this to disk as well. We can do the same for the male characters as well. Let's bring in our first male character. We won't be simulating any Vellum geometry on this. We can turn that off and click on Create Materials. And in the agent definition cache, save to disk. And similarly, for our second male character as well, we won't have any Vellum simulation. Simply create materials for it. And in the agent definition cache, save to disk. We can click on Reload to make sure our agents are coming in. Now for our final male character. For this character, we will be making the Vellum groups. So in the for Vellum wrangle, we can select the robe around his torso, as well as his skirt armor. Once you're happy with your selection, you can press enter. Now in the pin group, I will be selecting roughly the areas that I want to be pinned and animated with a geometry. And once you have that set up, we can create the materials for this character. And in the agent definition cache, click on save to disk. All our agents are now ready to be simulated for our final scene. To verify our agents, we can go back in our agent contact sheet. Inside our agent contact sheet node, right now it's erroring out because of our template node that is also coming in. Let's connect this to a null for now, just to avoid it from erroring out. So we have all our characters coming in. Now we have one character which is much smaller than the rest. We need to unify the size before we can proceed, for which I'll take an attribute triangle. I'll set the p scale for all our characters to 1. And for the character that is very tiny, I can select her separately and we can multiply her scale by 3. We have all our agents coming in and we can start building our setups. So first, I'll be building the setups for our first camera. So let's rename this to Crowd Motion Path Cam 1 and dive inside it. Now instead of our test agent, I'll be bringing in all my female and male characters. You can do that easily by replacing the number with an asterisk for both my male as well as female characters. Now instead of scattering it on the default grid, I want to scatter it on the ground that we created in the previous lesson. Let's take an object merge and I'll bring in my ground. I'll be painting the density where I want the crowds to be. But right now, this geometry is very low resolution for paint to work properly on it. So let's take a remesh node and set it to 1. And we'll remesh our ground geometry. So our ground now has enough detail for it to be painted over. Let's take an attribute paint. I'll increase the soft edge to 1. Let's turn off this ground so that our ground inside is clearly visible. And based on the camera, I'll keep the density the highest here. Since this will be acting as a midground and background layer, so we'll have the highest density in the midground. Now let's set the opacity to 0.5 and paint the rest of this area. This way, the far background will have the lowest density. Now let's take a scatter. In the density attribute, I'll input mask so that it only scatters the points where our attribute mask has been painted. And let's set the force total count to 200. Connect it to our crowd source. Now in our randomize tab, we can randomize the agent parameters and select all the agents that you want to input in your simulation. Again, we can also use expressions to control this. But since I want to control the weight for each agent in my scene, I'll be adding them separately. Once more, I can copy this attribute triangle and paste it here. We don't need to set the P scale for every agent, since crowdsource node automatically does that for us. So it will only multiply the scale for our female 3 agent. Let's get to our crowd motion path node. So we have none of our agents walking because we don't have any walking clips on them. So I'll go ahead and download and import all the walking clips, as well as the clapping, cheering and standing idle clips for all my agents from Mixmo. And be right back. Okay, so now for each of our generic agents, the idle clips as well as walking, cheering and clapping clips are set up. For both my mutants, I have the run clip with a run left and run right cycle. And for both my castle guards, I have the cheering while sitting cycle set up on them. Each of the animation is specifically downloaded for each of the character since they have different proportions. So now, if we head back to our motion path node, we can see that our crowds are moving. Now in our motion path follow node, we don't want our crowds to move only in one direction. So what I can do is in our motion path follow node, we have a match by attribute setting in which we can give it a target curve ID as well as a curve ID attribute. So let's take another attribute triangle. In this, I'll set a condition where 50% of our crowds will be using one curve and the other 50% will be using the second curve. We'll also use color to denote the agents based on their curve IDs. We have a parameter and a set of two agents now. One that will be using curve 1 and the other group that will be using curve 2. These can be two completely separate curves, but in my case, I'll just be reversing curve 1 to create curve 2. So let's go ahead and create our curve. I'll reset the current curve and just create a quick curve that moves across our scene. Let's take a resample and in treat polygons as, I'll set it to subdivision curves. I'll connect this to an attribute triangle where I'll set my curve ID attribute to 1. Let's also reverse this curve. Use the reverse node and give it a curve ID of 2. Now I can merge both of these. And now if you view the motion path follow node, we can see that our crowds are moving in two different directions. So this curve ID attribute is very useful and we can have as many curves as we want. And based on the IDs, the correct path will be following the curves. So now in our crowd motion path avoid, instead of a box, I'll get my buildings in. Let's once again set the maximum turn rate to 30 and the particle scale multiplier to 1. We can get rid of the crowd motion path edit for now. And in the viewport, I'll turn off the LOD agent reduction as well. Okay, so these agents will serve as our midground and background layers. Let's take a color node at the end and let's assign them some random colors. To close out this network, we can take an agent terrain adaptation node and connect it to our ground. Let's set the up vector to terrain normal, and we can turn off the simulation. This way, we can make sure that our characters don't have any weird orientations. We can move on to our second layer, which is our motion path transitions layer. So I'll call this cam1 as well. I will copy the object merge that we had in our motion paths node and paste it over in our transitions node. Now, in the crowdsource node, I'll go to the randomize agent primitive once more and enable it and select all my agents. Let's copy our attribute triangle for our female 3 to be scaled correctly and paste it here as well. Now in the agent transform group, instead of using the actual rig name, I'll use an expression for our root transforms. This way, it will get applied to the correct joints no matter what the rig name is. So we have our characters walking in. Let's increase the agent count to 50. And we can use groups to use various clip speeds on different characters. So that way, we can have a nice variation of speeds while also having a relatively similar movement between multiple agents. While you don't have to do this exercise, since we can also assign the walking cycle for all the characters at once, instead of doing it individually for each agent. This is just so we can get a more granular control on our agent speeds. For this setup, instead of scattering points on our ground, I'll be moving this in position post simulation. So let's first view our agent motion path layer node and verify that it's working. Next, we can make sure that our standing idle cycle is being triggered by transforming our box. So our characters are now coming to a stop. Let's reduce the random delay to 0.02. Now once our characters are coming to idle, we can re-add the cheering and clapping animation. We can play around with our motion path avoid settings to get something more desirable. Let's get rid of the motion path retime right now, and we can transform this to make them visible in our camera. Roughly, something like this works. Now, we can take a color node, and this time, instead of random, I'll be using random from attribute and use agent name. This way, we can verify that all our different agents are visible inside the camera frustum. So once you have all that coming in, we'll be using the same agents this time to do our Vellum simulation. I'll get rid of the duplicate agent in the front and copy the out crowd node. Now, I can bring in our Vellum on crowd setup, rename it to cam1 as well, and hop inside it. Let's get rid of our crowd setup since we'll be reusing the transition setup for this. And instead of merging in an agent, I'll merge in my crowd simulation from my motion part transitions node. So before we can simulate our crowds in Vellum, it is very important that we delete any penetrating characters as well as try to keep the off-screen characters to a minimal. This will make sure that our Vellum simulation is stable and not very heavy. I'll just take a blast. I'll set this to points and select the points in my final frame. Click on delete non-selected, and this way we won't have any points coming in that are outside the frame. Let's double check for penetrations. We have this group in the front penetrating. So I'll just take a transform node. First, I'll move the character in the back to make space for my other characters. Then, I'll copy the transform and I'll edit my character in the front. And finally, I added my last character so that they all have enough space to move around without penetrating each other. So once you have that ready, instead of a grid node, I'll take the object merge and bring in my ground for our Vellum simulation. Now, if you want, we can animate this ground as well, but I think we should be fine and not have any penetrations with the ground. So our Vellum setup is also now ready. We'll be simulating this later when we cache these for USD. Now, we can head to our next layer. For our next layer, we can skip the crowd motion path arcing layer node since we already have it set up in our relationships with crowd motion paths node. So let's take our relationships with crowd motion paths node directly and we can head to our next layer. We already have it set up for one mutant as well as one castle guard. I'll bring in my second mutant by adding an asterisk to our expression. In the crowd source node, I'll randomize the agent primitive. Let's set the number of agents to 20 and make sure we have the same number of castle guards. Now, let's bring in our second castle guard as well. Once again, I'll randomize the agent primitives and select both my castle guards. And we can transform this to a starting point that we would like based on our camera. I'll remove the crowd motion path edit for now. And let's recreate our curve. We have just a few agents coming in our camera custom, which is what we want for our first camera. And now, all our layers for our first camera are set up. So we can view these together. I'll re-enable the ground as well. So this is the final setup for our first camera. Now, similarly, I'll go ahead and create the other two cameras as well. Alright, so I've gone ahead and created setups for all three of my camera angles. For my second camera angle, I have a layer of the motion path crowds as well as agent relationship with motion paths, and the motion path transitions. Since it's a very wide angle, I won't be using any Vellum simulation on this angle. And for our third and final angle, I have the crowd motion paths. This time around, I am doing the Vellum simulation directly on the crowd motion path nodes. And then I have the agent relationship with crowd motion path with the arcing layer coming in as well. So now we have our entire crowd system set up. So that's it for this lesson. In the next lessons, we'll be learning how to render these out as well as optimize it using the new node in Solaris called Houdini Crowd Procedural. Thanks for watching and see you in the next lesson.